You Now show. Brought to you by the Club of Amsterdam.
Well, good morning, everybody. My name is Peter Cochrane. I'm at the University of Suffolk in the UK, and it's my pleasure to give you my view of 5G. And so before you is a slide set. If I stand aside, you'll be able to see the title. Please note this URL, petercochrane.com. If you go on there, you will be able to find this slide set. It's on SlideShare, and you can download it, and it is yours. There is no copyright. You can do with it what you will. And I'm using it to both augment this presentation and promote some general discussion. My view of 5G is slightly different to many people in the industry. I think it's probably been the single most overhyped technology ever. And one view of it is depicted right here on the slide as a Swiss Army knife. It does absolutely everything, but not very well. And to my mind, it has two key features that we really need, and nobody seems to mention them. It's not just the bandwidth, it's the latency. Latency is the single biggest killer for the applications that 5G is going to address. So here is the mobile industry hype, and it just seems to me that it seems very far from reality. We do not see these bandwidths in general. We don't have enough towers. And in actual fact, unusually, people don't seem to realize that the more wireless we have, then the more fiber we need. And there is only one way to get coverage for 5G that is dense and throughout society, and that is to put it on the end of optical fiber in every home and office. So the promise is very often graphed out like this. It is going to do absolutely everything, change everything, and rule the world. I'm not that optimistic. It has competition. 3, 4G are not going away anytime soon. And watch out, here comes Wi-Fi 6. And so the real wireless infrastructure for the future is a mix of many, many technologies and not a dominant 5G. 5G has got a place, but it is not the be-all and end-all of mobile and IoT and future communication. So I think the reality is going to be different. There's endless amounts of hype, mainly written by people who don't understand the technology, and I think they've got it badly wrong. I don't think we're going to see the kinds of capacities that are being advertised right now in the UK and the rest of Europe. There isn't the level of fiber optic capacity available to supply these kinds of bandwidths within about the next decade. So that's my reality wake-up moment. I'm excited by the low latency, and I'm going to give you a demonstration of a couple of technologies. So here is one from 1990.
And I'm going to have a look at the chair.
Paramedic Keith Hotchkiss wears a headset with a mini TV in front of his right eye, a microphone, headphones and a mini camera. He's linked via satellite and special telephone lines to the hospital.
Okay, Alan, can you hear me?
Yes, I can.
Right, we've got a 35-year-old gent involved in an RTA, front impact, high speed. He's complaining of difficulty with breathing, and the trachea is swinging to the left. I think this gent's got a tension pneumothorax of his right side, so I'm going to decompress it now.
Yeah, you're going to have to put a drain in. Have you done one before?
I'm only on a mannequin.
Right, now what I'm going to do...
Consultant Alan Jones in Accident and Emergency can guide the paramedic through the procedure, sending a diagram of the chest to the TV screen.
Now that was very clearly limited by bandwidth and latency. And this is a different version, but applied to the high-tech industry. And even in 1990, we could do this, and we could do it reasonably well, but latency was a killer when you were trying to do this over the Atlantic or across Europe, and the bandwidth was insufficient for the clarity of picture that you are now enjoying. this makes all the difference. This is where 5G comes in an awful lot of the time. But you can do this on Wi-Fi, and sometimes you can do it on 4G. So there are many different scenarios where we can realize this kind of facility. So here's a perspective. You really can't beat the laws of physics. The further you go, the weaker the signal, the lower the bandwidth. There's no way around that. If you want lots and lots of bandwidth, you have got to have cells closely packed together. And if you look at the 4G network, you probably need about 20 times the number of cell sites that we currently enjoy in the best of our 4G networks. The alternative to this is microcells, as previously stated, at the end of every fiber in every home and every office. Most countries do not have fiber to every home and every office, and ADSL isn't going to cut the mustard. Basically, these services of the augmented and virtual reality kind demand bidirectional bandwidth, not bandwidth in one direction. So this is the state of play. This is the way it is. And the free space loss is exponentially negative like this, and there's nothing you can do about it. So we just have to pack in more and more cell sites. And anybody that says you don't doesn't understand the technology. And you can see the data rates here as tested by Verizon with 4G versus 5G. These are quite realistic. There's an advantage over a short distance, but as the distance increases, then they get pretty much the same. This by AT&T, a bit more encouraging, but equally, you start talking about hundreds of meters for gigabit transmission systems, not tens of kilometers. The way that this is going is interesting. It depends on the country, it depends on the planning laws, and it depends on the attitude of the society to towers and masts. We're now seeing this kind of installation in a number of European cities. The units for the home are really quite neat. They pretty much look like a large Amazon Alexa box, sits in the windowsill, can possibly pick up a signal from a local hub to wireless hub to reinforce it, but mainly they have to be plugged into a fiber feed. And there's not any other option. It's not like there's some magic wireless solution here. It doesn't exist. So the energy demand also is a bit of a worry in terms of battery life. Our devices already are challenged by 4G on broadband. On 5G, it's even worse. The reality is that 5G as a standard has been pushed through, and it's really 4G on afterburners. And that means because they've used all the same fundamental signal coding protocols, we have got a huge amount of battery drain. And so 5G on the fly, there's a host of devices and they're going to compete with Wi-Fi. And this is going to be an interesting trade-off. My personal view is we need seamless handover between 3, 4, 5G and Wi-Fi to realize the dream of true mobility. And right now, internet traffic, Wi-Fi is transporting 55%, copper and fiber to the premises is only 45%, and 3 and 4G is only 5%. What is going to be interesting to see is, can 5G increase the share of internet traffic through specialized services such as VR and augmented reality? And that no one knows. I have a sneaky suspicion that from a reliability point of view, we will not see 5G suddenly becoming a 50% dominant connection in the last kilometer of the network. I do not see this picture changing vastly, but only time will tell. So I just want to give you a slight perspective here now of Industry 4.0, which is dependent upon artificial intelligence, robotics, biotech, and nanotech. And around the periphery of this, we have the Internet of Things to orchestrate the recycling and recovery and reuse of components and materials. And you have to ask the question, how is this going to work? How is the IoT going to be connected? Because a simple sum would say, if we have an Internet of Things between 50 and 250 billion things, and it all uses 5G, there is not enough energy on the planet to power it. And in actual fact, the dominant mode of the IoT is not over very long distances, it's over very short distances of 1 to 10 meters. And a new mode is emerging where the components of the IoT talk to each other, and the vast majority of things never actually connect to the internet. Now, this is a new network mode. It's a new way of thinking, and it looks like the IoT is going to be the dominant communications mode on the package. And we're going to see interesting things like these clusters on the left, and these various hubs on the right, and they will change very, very rapidly. We have no method of modeling this kind of network as of yet, and the thing is going to evolve. This is very much a biological network, and it's going to be an interesting new world. So let me give you another couple of examples. Every year, something between about 20 and 50,000 shipping containers are pushed overboard to stabilize container ships in a storm. There is no communication to those containers, and the wish is to have these containers talking to shore. Most of them can't see the sky. You can't afford 5G, you can't afford a satellite connection, but what you can do is have a very low-cost 10-year battery life unit where the containers can talk to each other, and you can get a mesh net where container to container, they get to the bridge and then ship to shore. That works, that is viable, and that sees all the information being amalgamated and then put onto 5G if it's on a truck, or if it's within reach of shore from a ship, but then on satellite links. The same is true of pallets and packages and goods in stores. And so this is the sort of picture. A further stretch on this is take a traffic jam. You will see on the major autobahns, freeways, motorways, jams that span 30, 40 kilometers possibly. Everybody's trying to communicate, and the cellular network fails. What doesn't fail, and what is coming, is that car to car, truck to truck, vehicle to vehicle communication, hopping down the freeway, autobahn, motorway, actually works. And that can be 5G, it can be Wi-Fi, or it can be the new standards being developed by the automotive industry for car-to-car communication through their radar systems, forward and rearward looking. And so this is a very interesting problem. We now have to think of vehicles as being networks on wheels. They aggregate information from throughout the vehicle, everything from tires to brake linings to engine performance, and that is communicated out. And the reality is the vehicles have many, many modes of communication. They can have 3, 4, 5G, they can have Wi-Fi that they can use car to car or at a filling station, and they can even use Bluetooth. And so this is a different kind of world and a different way of thinking. And I'm trying to encourage people to do PhDs in this area to start analyzing the sorts of networks that we are going to see and the ways they are going to communicate, and how all this fits together. There is a wonderful opportunity here to actually improve the reliability and the security of everything, because we will now have multi-channels. It means that any kind of malware attack or cyber attack on a vehicle can most likely be offset by using more than one communication channel. So a good example here is the wheel. The manufacturers of tires are looking at printing wheels with no pneumatic component, sprung structures, and then printing in the suspension and the electric motors and all the other components. And every single part of this picture has got sensors that communicate to the core of the vehicle, and we see all the dumb components becoming smart and vehicles becoming smart, but the vehicle itself becomes the server and the access point into the web. The tire does not use 5G, and nor could it. And it's a nonsense idea to suggest that this one standard for mobile could actually be used. So for people, we have a similar scenario where we scan our food, we buy it, we scan it, we exercise, we record what we do. We have many different ways of doing body readings, and if you've got a Japanese toilet, the latest Japanese toilets do an analysis of what comes out of your body, and then you have all the data for an informed diagnosis that may or may not involve the medic. It may be just you and AI. So this again sees possibly 5G playing a part, but for the most part, none of these devices need to go on the internet. They can aggregate all the information and it can be uploaded locally, or it can be sent over the internet. There are some new directions, people wearing hearing aids and earbuds. Then health sensors are now being experimented with, built into these devices. And so this is the new world. Robots at work, a similar story. If this surgeon here makes a mistake or learns something, he may well publish it in the Lancet, and gradually surgeons will learn about it. If one of these robots makes a mistake or learns something, then 160,000 robots worldwide understand the same problem at the same instant. This is exponential learning through machines of the kind we've not seen before. And so autonomous robots of various kind are being developed. And again, the communication on some of these devices couldn't possibly use 5G because they're too small, or they're in environments that are too difficult. And on the other hand, there are devices like this one, or machines like this one, where you might well say 5G isn't appropriate because it's going to be out in the field and it will be doing its own stuff, it will be autonomous, but it does not have to be that way. Autoimmunity, where we have our devices self-healing, also requires many different wireless standards. And here is a spectrum of those standards. And the mixed picture like this is the way I think it's going to go. So this is more or less reality already, but we can control everything in our homes from wherever we are. And we are now seeing this situation in China, which is leading the revolution. I was in China just 3 weeks ago. Thankfully, not managed to catch any infection, but they now have 6 million base stations deployed, and 5G is being rolled out as standard. I have to say the rest of the world is some way behind, and it'll be interesting to monitor the Chinese situation to see what they learn and what they have to bring to the party. So this is the presentation complete. If you visit my homepage, petercochrane.com, and you have a look on the presentation sets and the publications, you will find every aspect of this short presentation amplified in greater depth by even more material. And should you wish to have a discourse, my contact details are available, and I will gladly communicate with you at any time in the future about this. So thank you very much, and Felix, back to you.